So there's one more piece we need to add to our steps for graphing the perfect function. We need to figure out the leading coefficient test. So just to get the terminology down, if you see this, it means x approaches infinity, and this one means as x approaches negative infinity. So what we want to do is figure out what the graph is doing at the ends of the graph. Sometimes we'll call this the end behavior. So, have a look at this first one. Y equals x cubed minus x. Do you remember the parent function for x cubed? Do you know what it looks like? Remember that makes that little S shape? So something like that? Well, if we were to go back and draw in our x and y axes, something like that, can you tell me what happens to y as x gets bigger? As x goes more and more this way, y goes more and more this way. So this is how you would look at it. As x is going to infinity, or as x is getting bigger, y is getting bigger. As x is getting bigger, y is getting bigger. So the next one says as x is getting smaller, or as x is going in negative infinity. That's this direction. As x is getting smaller, what is y doing? Y is getting smaller. So y is going to negative infinity. The degree of your polynomial, in this case, is odd because of that 3. The degree of the polynomial determines the shape of your graph. The sign of the leading coefficient, in this case, is positive. It's going to determine the direction your graph is pointing. So look at the next one. Remember, x cubed makes the S shape, but what about the negative? What does that do? That reflects it over the x-axis. So if you put a negative in front of your x cubed, it goes this direction. So the degree of this one is odd. The sign of the leading coefficient is negative, and that's how we get this shape. So look at your x's. As x is getting bigger, what is y doing? Y is actually getting smaller, so it's going to negative infinity. And as x is getting smaller, x is going to the left, what's y doing? Y is getting bigger, so y is going to infinity. Do you remember if you have y equals x squared, what that looks like? That's going to be a parabola, right? So it looks something like that. And if you have y equals negative x squared, it's a parabola as well, except what is different? It's upside down, right? It's pointing down. So this negative determines that it points down. This positive determines that it points up. The square determines that it looks like a parabola. Well, what I want you to take away from this is, anytime you have an even exponent, your graph will look kind of like a parabola, but you could have crazy stuff going on in the middle. So like if you have x to the 4th, like these two are right here, you could have something that looks like this. Or you could have something that looks like this. You could have some crazy stuff. But the general shape of the graph is still that U shape with crazy stuff in the middle. And that's also true for odd functions. If you have any odd function, it's going to look like this, but you could have crazy stuff going on in the middle. Alright? So look at number 3. We know that it's even, so we know that the general shape is like this. Of course we have crazy stuff in the middle. Let's not worry too much about that just yet. So we know that it's an even polynomial. The sign of the leading coefficient is positive. As x is getting bigger, what is y doing? Y is getting bigger. As x is getting smaller, what is y doing? Y is getting bigger. Okay? So look at number 4. The degree of the polynomial is still even, but this time the sign of the leading coefficient is negative. So if you have a look at that one, it's like this. As x is getting bigger, what's y doing? It's getting smaller. And as x is getting smaller, what's y doing? Y is also getting smaller. So this is the leading coefficient test.